We just went through Fabric data pipeline, how it orchestrates different compute work, and how compute is achieved using notebook. Fabric itself is a very powerful tool, and Microsoft is putting all its bet onto Fabric and adding more features every day. But as you can see, it's still in some places it's still not mature enough. And after all, it's new. It's less than 1 year old so far. So when you start your working, when you get to your jobs, very likely you are not going to use Fabric immediately. Probably in a smaller scale. Very likely you will also be utilizing other tools such as Databricks or Azure Synapse Analytics. For this reason, the next two sessions we are going to talk about Databricks and Azure Synapse Analytics and provide you with an overview of how they look like. As you look into these two, you will realize that the underlying technology is very similar. Fabric and Databricks both use Spark and Delta Lake technology. Fabric and Azure Synapse Analytics also utilize Lakehouse and data pipeline and data factory. A lot of this common Microsoft technology. It is how these are organized and named that are different. So let's get into the names and the interfaces of these two, see how they work. You can definitely compare and contrast them to how this works in Fabric. So starting with the Databricks. Databricks used to have older architecture. If you see something called the data plane or something, that was the older architecture. In year 2024, they actually changed their architecture a little bit. So in this architecture, you have the control plane, which is you can relate this to the administrative nodes that we talked about before. These are the administrative nodes providing the user interface, and users will access the control plane to access the compute and storage. So you also have the compute plane, two of them, classic and serverless. Classic compute plane used to be the only plane that you will be working with. The serverless compute plane is a new one, but the underlying design is the same. In each of these compute plane, you have compute and storage. And inside this compute and storage, the compute of Databricks data architecture is cluster, Spark cluster. We talked about Databricks. It was built on top of Spark, right? So in each cluster, you have Spark core. You have the Spark core communicates with the storage, which are all storage, cloud-based storage, like Azure Blob Storage, and forms the on top of this storage, you build the Delta Lake. You build a Delta Lake, and Spark core will communicate with that data lake. This Spark core will further offer the data through RDD API in the form of Spark SQL and the Spark data frame. So you will be running your code against Spark SQL or Spark data frame in a cluster. And this code will run eventually touches the data lake house that was stored in Delta Lake. The compute is done in Spark through Spark cluster. Compute is done in Databricks through Spark cluster. Databricks compute is built on top of Apache Spark. The primary unit of operation in Spark is cluster. It's a set of virtual machines, also called nodes. These nodes are organized together for workload. Typically, you will have one driver node which controls multiple worker nodes. All data processing are done in the worker nodes, and driver nodes does some of a control. And I should back off on the previous statement. Most of the heavy lifting of the data processing is done in worker nodes. Driver nodes has some final touch and some orchestration of the data and indicate some kind of shuffling stuff. So driver nodes, most of the work is still done in worker nodes, and driver nodes is in charge of management and the control, and a little bit data processing. Now there are sometimes a single node cluster where one node will behave both as a driver and a worker, but this is extremely rare and only used for development or educational purpose. You should expect to see a multi-node cluster when you start your your work. Data is stored in Databricks in the hierarchy of Unity catalog. So we talked about cluster as compute before. Now, when you store data, it's stored in the in the hierarchy of Unity catalog. Unity catalog provides a centralized cross-workspace control over access control. So you will have the Unity catalog in charge of the storage, and the workspace will offer the compute to process those storage. And these are the things that the Unity catalog define. Tables, views, all familiar stuff, functions, roll up to schema, roll up to catalog, and there are some auxiliary objects to support the operation of Spark. But fundamentally, that's tables, and you can utilize functions. So this is the user interface of Databricks. You have the workspace, which is a grouping of different tools. You have a compute. That is the definition of clusters. You have a catalog. This is how you will define your storage. Then you will have a SQL and data engineering, where you can define how you define your SQL, your notebook, and your jobs. Job is basically a notebook. You run it, then it's a job. So let's get back to the Azure interface, and let me type in Azure. Oh, I don't even need to type in Azure Databricks. So I created some workspaces inside your Azure Databricks account. You can create your workspace. When you click on here, you can launch the workspace in a different window. Here, Azure is controlling the management, the properties of the workspace itself. The operation happens in workspace. So inside workspace, now I'm going through the control plane, accessing its user interface. As we see, there's workspace with a definition of your development work, mostly your SQL and the Python notebook or Scala notebook, and your repo. This repo is actually a CIC, the DevOps repo, like a GitHub repo or something. So you have the repo, you have the notebooks, some kind of different notebooks. So, but first, let's go to compute. Compute is where you can create as a cluster, right? There's a warning because this is a trial. I'm not sure whether I can create a computer or not, but at least I can show you what is touched. So you can create a cluster, and you can have multi-node, single node, and you will define your Spark version and what kind of CPU you will be utilizing. And we mentioned that you have a driver node, right? And you can have multiple worker nodes. You can have a number of worker nodes. So this is cluster. You create a cluster, basically is a driver node with a series of worker nodes that can do data processing. Now let's go to catalog. Catalog is where you define your tables and storage, right? So here you have the samples, sample database. I'm not going to start that, but basically, as you can see, this is schema, and you will have a different, this is catalog, and you will have different tables under that. You can also define your the catalog and the schema under this catalog explorer. So this is how you define compute and the storage, and you can define, of course, SQL editor. You can create a SQL running against different SQL warehouse. Currently, I didn't start anything, but this is how you would like to type in your SQL. And then there's job runs. I didn't start any job, but basically, when you have a notebook, you can run that. There's no jobs. But when you define a notebook in my workspace, okay, I can create a new notebook, and the rest is familiar stuff of creating notebook, adding SQL or Python code, start running. Once it's run, it's a job. and it will display it here, or you can use the SQL editor directly against the SQL House for interactive processing.